In this video, we're going to look at balancing chemical equations on page 3 and 4 of your homework packet. Grab a little marker here and then get started. So this is page 3 of your homework packet, and it says balancing chemical equations. So here I have one, carbon plus oxygen. We're going to find out that that tends to travel in pairs, okay, forms carbon dioxide or CO2. So let's just get used to a couple terms here. Reactants are on the left side of the equation. It's what you start with. The arrow means reacts to forms or makes or produces or yields. All of those are like synonyms for saying kind of this process when a reactant goes to products. The products in this case are CO2 on the right side. Little numbers like this are called subscripts, okay, behind them. And then big numbers in front, this one doesn't have any, are called coefficients. So because there's no number in front, the coefficients in each case would be 1, and typically if the coefficient is 1, we don't put it there. Don't worry about this term moles. Think of molecules for now. We're going to learn about moles at the end of January, beginning of February. Okay, here's the whole thing behind balanced equation. Bonds, old bonds break, new bonds form, but you don't create new atoms or destroy atoms, you just rearrange them. So the atoms are neither created nor destroyed, so the number of atoms of each type are the same on each side. So at the end of the day, I should have the same number of carbons on the left and on the right. And then this should have the same number of oxygens on the left and on the right. In this case, I have 1 carbon here, 1 carbon here. I have 2 oxygens here, 2 oxygens here. So that is already a balanced chemical equation. Okay, so sometimes we don't have a balanced equation and we got to change by putting coefficients in front. Okay, we can't change this little subscript balancers, but we can put numbers out in front like coefficients to make it balance. Okay, in other words, we can't change the chemical formula that's already there, but we can change how many we have, and that's what the coefficients refer to. Okay, so now I have carbon plus oxygen, which is O2, it travels in pairs, forms carbon monoxide. Okay, so this is a different chemical reaction because carbon monoxide is different than carbon dioxide. So we got carbon plus O2. Now I look at it, what's different? Well, 1 carbon, but I got 2 oxygens here, so I need 2 oxygens here. I can't just put a 2 down here as a subscript because I don't want to change the formula, but I can put a 2 out in front. So if I have 2 molecules of CO, now I have 2 atoms, or if I have 2 molecules of CO, I have 2 atoms of O, and I have 2 atoms of O right here. But now I got 2 atoms of carbon, so I have to put a 2 in front here. This is now a balanced equation. 2 carbons on the left, 2 carbons on the right. 2 oxygens on the left, 2 oxygens on the right. Notice the number in front of a coefficient refers to all the elements behind it get multiplied by that number. Okay, so that is the balanced equation for this. We showed an example here. Here are some hints. Start simple, find out what's different, and then attack there and try to make that right. Okay, we're going to learn this later about the polyatomics and doing water last, but at the end you can always go back and check to make sure you have a conservation of atoms. The same number on the left is on the right. So let's go to this one right here. And this one says MgO2 and MgO. I'm just going to scroll back up here a little bit. And I look at this and say, oh, Mg's are the same, but O2 is different. So I can't change my chemical formula. I can't put like a 2 right here. But what I can do is change how many Mg's I have. Okay, so I'm going to put in a 2 right here telling me I have 2 MgOs. Maybe I'll just draw that down here too, saying, hey, I have MgO not once, but twice. Okay, I'm going to do a little sloppy draw, I guess. Okay, so I have that. Okay, so I have Mg connected to O, Mg connected to O 2 times. Okay, I have 1 O2, and the 2 instead of in front behind it means they're actually connected together. Okay. Now, when I did this, now I have 2 Mg's on this side, so I better throw an Mg on there. Can I just throw something over here? Yes, you can put in a coefficient in, which means changing how many you have. you just can't change this formula. I can't just change this formula to MgO2 because Mg has a +2 charge, O has -2 charge, and then that would mess up that formula. But I can put coefficients out in front. This is now a balanced equation. 2Mg on the left, as seen here, 2Mg on the right. 2 oxygens, 2 oxygens. Notice again, the O2 is sitting here. The O's are connected when I have that little connector there. And if I put the 2 there, if I put the 2 out in front, then the O's would be separate from each other. All right, let's go to another example. And let's roll this up. Let's try this again. All right, I'm going to look at this example on page number 4. I got KClO3, and then I got the yield. So that's going to be my dividing line, forms KCl and O2. Okay, and this is a correct formula. ClO3 is an ion, the chloride ion with a -1 charge, K is a +1. So this is a balanced formula. I can't change that. K plus and Cl minus are a balanced formula, and oxygen is one of those that travels in pairs by itself. Now, when I can look at it and say, it looks like the Ks are the same. It looks like the Cls are the same. What's different? Oxygen's 3, oxygen's 2 over here. What's the smallest number that 2 and 3 go into? It's 6. So what I'm going to do, think multiplying, not adding, I'm going to put a 2 out in front here and a 3 out in front here. And if I do that, I get 2 times 3 gives me 6 oxygens here. 3 times 2 gives me 6 oxygens here. If I put a 2 out in front, it means I have 2 Ks, so I better put a 2 here. It also means I have 2 Cls. Well, I have 2 Cls here, so that looks balanced. The 2 Ks balanced, the 2 Ks balanced, the 2 Cls balanced, the 2 Cls balanced. And 2 times 3 is 6 oxygens. 3 times 2 is 6 oxygens. Let's look at a picture of that. So again, I looked at what was different, corrected it by putting coefficients, and then I checked my answers. Okay, so it looks like we lost our numbers. Just gonna throw those in here quick. Here, that color, let's switch it up here. Okay, let's try drawing this. So we said this was 2, 2, and 3. And I just drew a picture. What does 2 KClO3s look like? This big ion, ClO3 with a K, and a KCl and an O2. But what I did was, if I have 3 O2s, I got 1, 2, 3, 4, 5, 6 O's now. I have 1, 2, 3, 4, 5, 6 O's. So that balances. 2 Ks, 2 Ks, and 2 Cls, 2 Cls. Notice this is my big line that divides. I have the same number of Ks on the left of the line, same number of Ks on the right, same number of Cls on the left, same number of Cls on the right, same number of O's on the left, same number of O's on the right. All right, let's go to one more example for this video. I'm going to clear this out, and let's go to one more page. This is number 10 on page 4, and it looks like this. Oh, this is getting more. There's calcium, there's oxygen, there's hydrogen, there's nitrogen. There's a lot of different things going on. So there are a couple hints that I'm just going to go back and look at when we did our reactions. And that was start simple, what's different? Group polyatomic ions if possible. So we're going to do some of that. And if in doubt, balance the H2O last. We're also going to do that. So let's go back here and try a couple of those things with this problem. Okay, so first off, it says group polyatomics. We probably remember the nitrate group or the NO3 group from the common ion chart. So instead of thinking it as an N and 3 O's, I'm going to think of it as a group of NO3. So I look at my hand, instead of saying, oh, 5 fingers or 4 fingers and a thumb, I just think of it as a hand, okay? Same thing here, and it's a lot easier to keep track of counting fingers. I can just count hands. So that's what I'm going to do here. I'm just going to guess here and assume this is a 1. So if there's no coefficient in front, we'll assume it's 1. You don't have to write the 1 in. But 1 times 2 would be 2 groups of NO3. So I'm going to put a 2 in front there. Now I got a calcium, 1 calcium, so I'm going to assume this is a 1 right here. Okay, so I got 1 calcium, 1 calcium. I'm going to skip that OH and the H's for now. We're going to say they're going to do that last. I got 2 groups of NO3. I got 2 groups of NO3. You can do the H2Os and keep track of that. I think it's easier when you have H2O. Sometimes it's easier to think of that as an H plus connected to an OH minus. So I'm going to call this HOH, and I think it makes it a little bit easier. And when I do this, call this HOH. In some cases, that does make it easier. If I have 2 groups of OH and I have 2 extra H's, remember these O's were already accounted for. So I have 2 groups of OH and 2 H's. Oh, 2 groups of OH and 2 H's would mean this would be a 2 out in front. Right here, 2 H's, 2 H's, and 2 groups of OH, 2 groups of OH. Okay, and then I got my 2 groups of NO3 here, my 2 groups of NO3, and my 1 Ca and 1 Ca. So the hint here was grouping off the polyatomics, and then the HOHs I grouped off and did that last. But I could say 2 H's, 2 more H's is 4 H's, and 2 O's, and say, oh, that's 2 H2O's. Or I could break into HOH, and it does make it a little bit easier to handle that. Let's just scroll down and look a little bit at that picture here. I think it's going to get locked up here. Let's just take a look. So we look at this, and I think we said this was a 1. So we got CaOH2, and then we have, whoops, scroll this down just a little bit more. Let's clear this out, and we'll just put our numbers back in. Sorry about that. We'll put a 1 here, and we said 2 here, and we said 1 here, and we said 2 here. When I thought of the H2Os as HOHs, I thought of this as CaOH2. I roped off the NO3s, like I have here, and I roped off this NO3. And what happens? I got a CaOH2, a Ca and a Ca. I got 2 groups of NO3, 1 there and 1 there, 1 there and 1 there. I have 2 groups of OH, so OH and OH. And I have these 2 extra hydrogens right here and here, and that matches to here and here. So that is a hint, a little bit of trial and error, but if you look for something different, then you can double check at the end to make sure things match up. But you can group your polyatomics, and you can even split up H2O into H plus and OH minus by doing that last. Okay, these are some hints. Look at page notes on page 3, and then try pages 4 and 5. And there's some keys to check a lot of your answers for this. Thank you.